Right. Good day, everyone. I want to use this opportunity to have our physics 101 solved to help us cope the crisis we're into this season. So I want each and every one of us to follow me. Please do subscribe to my channel and give me a thumb up and hit the bell so that you would always get my notifications each time I produce um, a video. Thank you. Now, I want to take time to solve problems on vectors. If you look at it critically now, you will see I have questions 1, 2, 3, 4, 5, and 6, and all adapted from our textbook, Mechanics, Heats, and Properties of Matter. So I'll be solving the problems in my various videos, but I'm going to start with this one. Now, understand that vectors are defined as any quantity that has both magnitude, that is size, and direction. And examples of vectors are force, moment, power, velocity, pressure, impulse. Then, as opposed to scalars, scalars do not have direction, but they have magnitude, that is, they have size. Example is walk, distance, speed, pressure, and time. Okay, now in vector representation, an arrowhead line is used to show the direction of the vector. But we're not interested in showing how to resolve vectors in this video. What this video is all about is on how to multiply vectors. So, but I'm going to give you some of the terms we often use. Example, when you have an arrowhead and an A like this, it signifies vector A. And when you have an A in a parallel line, enclosed in a parallel line, we call that magnitude A or modulus of A. And each time you want to calculate magnitude of a vector or modulus of a vector, you always use square root of x squared plus y squared plus z squared, which also signifies the values you have for your I, your j, and your k. That's for unit vectors in those directions. Okay, now when a vector is represented in space, normally it is usually denoted by ij and k. That is in three different directions. We have the I direction, we have the j direction, and we have the k direction. Okay, now in this video, we're going to be interested in unit vectors. We're going to be interested in unit vectors. And in this case, I'm not going to talk about addition of vectors because that will be coming up in my other videos by request, and then subtraction of vectors that will also be coming up by request. But I want us to major on multiplication of vectors. That's where I'm actually going to head to. Now, if you look at my number two question says determine the magnitude of a unit vector in the diagram, sorry please, in the direction of the vector minus 6 1 plus 3j minus 2k. So I'm to determine the magnitude of that vector, and here now we solved it. And remember I told you that magnitude of a vector can be simply square root of x squared plus y squared plus z squared. Now the vector I'm dealing with is minus 6i plus 3j minus 2k. So in solving this, I will only isolate the numbers from the letters. So I will pick out the minus 6. Remember that the sign is very important. You have to pick out the sign too. This is minus 6, this is plus 3, and this is minus 2. Please, this is minus 2. This is minus 2, and this is minus 2, please. Minus 2. Hence, we are going to have minus 6 square plus 3 square minus 2 square. So that will be giving us minus 6 square is 36. Then 9 square is 3 square is 9. And then minus 2 square will give us 4. Give us 4. Okay. So using my calculator, 36 plus 9 plus 4. That will give us 49. Then take the square root of 49. That will give us 7. So take the square root of 49 as square root 49. That will give us, please, this is wrong. That will give us magnitude equal to 7 units. and the dots. All right, please, I'll be shifting my next videos on multiplication of vectors. I want to make the video very short so that we'll be able to accommodate it. So I'll be bringing up in my next videos multiplication of vectors. They are going to explain how to know when you use dot product and how to know when you use cross products and what they all symbolize while I solve the other problems in the question. Thank you. Please do subscribe to my channel, thumbs up, and then hit the bell so you can get notifications. Thank you. Bye.